Section 5.3 is going to be about multiplication. We know about polynomials. We know that to add or subtract polynomials, all we have to do is combine like terms. In order to do multiplication, we need to have a little bit of a reminder. So I'm going to say review the product rule. We talked about the product rule when we went over section 5.1. The product rule said if you have some base to a power, so I have x to the a, and you multiply it by the same base to a power, what do you do with the exponents? You add them. This will be x to the a plus b. So what you have to remember is that when you're doing addition, the exponents have to be identical. But when you're doing multiplication, they do not. Okay? So I'm going to use this property. Let me do one quick example. If you have x to the second times x to the third, what does the rule say you're supposed to do with those exponents? You're going to add them. So it'll be x to the fifth. X to the fifth. Okay? So we're going to use that. We're going to multiply, and then we're probably going to use a good bit of the distributive property. All right, the first problem. I have negative 2a. Whoops, this is actually number 2. Let me scoot up. Here's the first problem. I have in parentheses negative 4.2 x to the fifth times 7x to the seventh. Not really sure why they chose to use a decimal in there, but it doesn't matter. You're just going to multiply negative 4.2 times 7. What are we going to get? Negative 29.4. Negative times positive is negative, and I think I multiplied right. When you have x to the fifth times x to the seventh, what will that give you? X to the 12th. You do not need like terms to multiply. Okay, I multiplied the numbers for negative 29.4. No, it's not. Y'all multiply negative 4.2 times 7 on your calculator. Just regular old multiplication.
29.4.
29.4. It was a negative times a positive. What you might not be seeing is this. I'm going to use the commutative property, and I'm going to say that's negative 4.2 times 7 times x to the fifth times x to the seventh. All I did was reorganize this product of 1, 2, 3, 4 factors. Now, if I multiply those, I get negative 29.4. If I multiply these, I have to use the product rule. And what does the product rule say to do with the 5 and the 7? Add them. X to the 12th. Okay? We'll do lots of multiplication before the rest of the class is over. I have negative 2a times a plus 4. This time, I'm multiplying a monomial times a binomial, and I need to use the distributive property. I'm going to use the distributive property, and I'm going to use the product rule. What is negative 2a times an implied 1a? Negative 2a to the second power, because this had a 1 and this had a 1, and the product rule said I should add the exponents. What's negative 2a times 4? Negative 8a. And that's my product. I use distributive property and I use the product rule. All right, we're going to do it again in the next problem. In number 3, I have 3x times 5x squared minus 5x plus 2. distributive property. What's 3x times 5x squared?
15x squared.
15x to the third, because I add the implied 1 to the 2. 3x times negative 5x is negative 15x squared, because I add the implied exponents of 1s. And then I multiply 3x times 2 for 6x. Is that okay? The product rule, I have to add exponents when I multiply.
You don't like combine them at the end?
Okay, very good question. I can combine them only if they are now like terms, but they're not. Remember, multiplication works for anything, but addition only works if they're alike. Glad you asked that. Number 4. Now, on problem number 4, and I'm going to write it right over here to the side, I have a binomial just a moment. I have a binomial a plus 4 times a binomial a minus 7. Okay, now the only skill I have in my pocket right now is the distributive property, but I'm going to have to use it almost twice. I'm going to distribute first of all the a, and when I get through with that, then I'm going to distribute the positive 4. So what's a times a? It's a squared. What's a times negative 7? Negative 7a. All right, now I'm going to distribute the 4. I have 4 times a is 4a, and I have 4 times negative 7 is 28, and it's negative. In that expression, are any of those terms like terms?
The negative 7a and the 4a.
Okay, there are some like terms, so I can add those. I have a squared, and how many a's? Negative 3a minus 28. So I multiplied a binomial times a binomial, and I got a trinomial. That won't always happen. It happens a lot, though. So I use the distributive property. This is problem number 5, and you are asked to multiply, well, or to find 2y plus 7 quantities squared. You do not square it by squaring this term and this term. Because what does it mean to square something? Multiply it by itself. So it's 2y plus 7 times 2y plus 7. And I need to use the distributive property again. First, I'm going to distribute the 2y. 2y times 2y is 4y squared, and 2y times 7 is 14y. Then I'm going to turn around and distribute the 7. 7 times 2y is 14y, and 7 times 7 is 49. Now, something happens when you square a binomial. When you distribute, the last term of the first group is identical to the first term of the last group. That's always going to happen. I just wanted to point it out to you. And do you agree that those are like terms?
Yes.
So I'm going to end up with 4y squared plus 28y plus 49. Try to remember that we've talked about that when we get into lesson 5.4. Okay? problem number 6. Number 6 asks us to multiply x plus 7 times x cubed minus 2x plus 6. All I have, distributive property. So first, I'm going to distribute the x. What's x times x to the third? X to the fourth. What's x times negative 2x? It's negative 2x squared. And x times 6 is 6x. All right, now I'm going to distribute the 7. That gives me 7 times x to the third is 7x to the third. 7 times negative 2x is negative 14x. And 7 times 6 is 42. When you go through and think about combining like terms, please do them in descending order. In other words, highest power down to lowest. Yes, question?
When you do the distributive property, why do you add the exponent on the x and not on the 7? Why is it not implied on the 7?
Okay, because its exponent, if you remember back when we talked about degree of a term, the power on this one would be an x to the 0. So when I multiply a 7 times that, I have a 0 to add to it. Okay? All right, so I'm going to start out with an x to the fourth, and there are no other x to the fourth, so I'll list that one first. What will I write as my second term? I will go down here and say the next low power is 7x to the third, and it has no like terms. Then I have a minus 2x squared, and it doesn't have any like terms. But what about the x's? There are two terms which are both x's. Combine those for how much? Negative 8x. And then finally, I have a single constant of plus 42. So that was a long process.
Well, that's good to know to go like in the descending order, because like I would have been like still all working on it.
They would have just been everywhere. I don't know whether MathLab would have counted it wrong if it were in some other order. This is traditional order. Okay? All right, let's look at 7 and 8. All right, number 7, let's see if I can. Okay, I can't really do that. I was trying to get some extra lines because, oh, yeah, I just got less lines. All right. I'm going to go down to the bottom and do number 7 because I might need a lot of room. Number 7 asks me to take x minus 6 and cube it. Well, what does it mean to cube something? Yes, I'm going to have x plus 6 times x plus 6 times x plus 6.
Why did you change the?
Because that's the kind of day I'm having. But I'm glad somebody's not having that day so that you can keep me maybe going straight on this. If you go back and review this video, just remember how hard it was for me. All right. I'm going to go ahead and multiply the first two. All right, using the distributive property, x times x gives me x squared. X times negative 6 gives me negative 6x. Moving over to the negative 6, negative 6 times x is another negative 6x. And negative 6 times negative 6 is plus 36. Now that's all I'm doing for that step. The last factor just came straight down. Can I maybe simplify a little in that first set of parentheses? Do you have some like terms you could combine? All right, so I did the product of the first two, and I got this, which I am now simplifying to be x squared minus 12x plus 36, and that's times x minus 6. Question? No? Okay.
Wait, why didn't we do the last one?
We're going to. Okay, I just needed to do them one at a time. So I took care of this product, and now I'm going to multiply this times this. I think you may, I'm not sure, but I think there's one of these on your test. Uh-huh. Okay. Now, this step that I'm about to do is optional. When I use the distributive property, and I have a trinomial and I have a binomial, this may just be me. I like the binomial written on the left. It seems to make more sense or be a little easier to work with the smaller polynomial being distributed to the bigger one. That's not an absolute must. I just used the commutative property that said I could change the positions. So now I need to use the distributive property. And I'm going to write something maybe a little differently this time. I'm going to multiply x times x squared for x to the third. I'm going to multiply x times negative 12x for negative 12x squared. And I'm going to multiply x times 36 for 36x. Now this is where I'm about to write something a little differently. When I multiply negative 6 times x squared, I get negative 6x squared. It's a like term with this one. So I'm just going to write it underneath there. This, and by the way, y'all didn't scream at me. You probably saw it. That was supposed to be 36x. If you wrote down what I wrote down, please fix yours. Okay. When I went to the second term and distributed, negative 6 times x squared is negative 6x squared. Instead of tacking it on down here, I decided to line it up under the like term. Now, what's negative 6 times negative 12x? Positive 72x. And I choose to line it up under the other term that was an x. All that's doing is physically putting my like terms close together. And then what's negative 6 times 36? It's negative, I think it's 216. Somebody? Yes. Okay, thank you. Now, I wrote these where they lined up under as like terms. So now it's a little easier to combine. I have x to the third. I have minus 18x squared. I have plus 108x minus 216. I would have gotten exactly the same answer if I had not lined them up like I chose to. This just makes finishing the problem a little easier. All of this is problem number 7. Yes, but remember, you've got a take-home test right now. So if you've got one, you've got time and all the room you want to work on that.
When is that test?
The test is due next Tuesday. All right. We're going to do problem number 8, and then that's the last one we're going to do in this lesson, even though there are, well, I think it is. There are some more multiplication problems, but it's just more of the same. So let me copy down number 8. And it is, oh, let me go back to the instructions. Problem number 8 says, find the following product, use vertical multiplication. Now, I guess I'm not going to make it a secret that I'm not a fan of vertical multiplication. I'll show it to you, and you might love it, and it's fine. I'm just not a huge fan. Now, the polynomials are 2x squared minus 6x minus 8, and I'm supposed to multiply it by x plus 7. When you do it vertically, you put the polynomial with the larger number of terms on top, and the smaller one on bottom. And I know you remember doing multiplication with multi-digit numbers in your past. What do? You multiply first by the first digit. 7 times negative 8 is negative 56. 7 times negative 6x is negative 42x. 7 times 2x squared is 14x squared. So that really felt a little bit like the distributive property. In multiplication, you then leave a blank here, you scoot over to the x, and you multiply again. X times negative 8 is negative 8x. X times negative 6 is 6x is negative 6x squared. And x times 2x squared is 2x to the third. What's the nice thing about vertical multiplication? You've got that nice setup of like terms lined up under each other. So I have 2x cubed plus 8x squared minus 50x minus 56.
Can you do it like that every time?
Certainly, yes. And it may appeal to you.
I do it. That's the regular problem.
The original problem, when you read about it, it has it written out horizontally. But it's set up here to use vertical, although MATLAB really has no clue what you're doing. If you like vertical, you use vertical. If you want to, you could have done it as the distributive property, which I'm going to redo the problem. And I'm going to line up my like terms anyway. So I'm going to multiply x times 2x squared for 2x cubed. I'm going to multiply x times negative 6x for negative 6x squared. X times negative 8 for negative 8x. Then I'm going to distribute the 7. 7 times 2x squared is positive 14x squared, and I put it under my x squared. 7 times negative 6x is negative 42x. And 7 times negative 8 is negative 56. Does this look just like it did over here? I mean, maybe reversed, but the same idea. I have 2x cubed plus 8x squared minus 50x minus 56. So, use whichever method you like. Vertical, distributive property. Okay, more of same on 9 through whatever. Okay, that's it for 5-3.